Then the bandpass filter with 1 kilowatt center frequency should pass the signal as it is, and on other frequencies it should basically give zero output. And for same way, if your input is 3 kilohertz, the bandpass filter 2 should give like it will pass the input, but for other frequency it will attenuate it and output should be zero. And then so once that you do, then adder again it's simple. So like these two inputs to the adder is basically from the filters, and the output of the adder should be the sum of v in1 and v in2. And then so yeah, this is adder. As for experiment 3, uh, H bridge driver, so here uh, the output, uh, now if you in the simulator, the output basically will be like switching, like at the output it will be like a PWM wave, like it will be like a pulse wave basically with varying uh, duty cycle. And like you can maybe like here you can basically add a low pass filter to get back, ideally you should get back this input here if you add a low pass filter here. So one thing here is that this non overlap clock generator should be correctly made, because otherwise there will be a uh, direct short from we supply to ground, which will cause infinite current to flow. So yeah, so the output of this uh, H bridge driver, basically V out P will be like a pulse varying PWM signal, and V out N will also be um, like 180-degree out of phase this PWM signal, and that will basically drive the speaker, and the speaker will give a sound.
How do we protect that? Because you mentioned it can go infinite current, right?
Yeah.
So,
So to avoid that, basically this that's why you have a non-overlap clock generator here. So the role of this and the, so basically the role of this non-overlap clock generator is that at any point of time, uh, if this is on, this will be off, or if this is on, this will be off. So at any point of time, both of them won't be like switched on. That's why you have this non-overlap clock generator. So this will make sure that there's no short from supply to ground.
okay, okay, only one will be on at a time because of.
But one question, if I may.
Yeah.
This non-overlap generator is basically a set reset latch, right?
Mm. Uh, yeah. In a way, it is.
So what I am trying to say is, if D is 1,
Okay.
then Q will be 1 and Q dash will be 0, right?
If
And
D
vice versa.
if D is one, this is Q will be one. If D is one, Q is one, and Q dash will be zero. Yeah, you are correct.
Right? Now, if these two outputs are connected to the two buffers in the page below, yeah, there,
Huh.
then what is going to happen is, let's say the upper one, I connect it to Q, okay?
Okay.
and lower one I connect it to Q bar. What
Okay.
will happen is, because of the two inverters in series, always when Q is low, QP will turn on.
When Q is low, QP will turn on.
QP
Correct.
will turn on, correct? And when Q bar is high, QN will turn on.
Q bar is high.
Yes.
So you're giving Q bar here in the
No, Q.
uh, from here, like Q bar is going up, right?
But whichever way it is done,
Okay.
I think the result will be the same. So let's say if we connect Q bar there,
Okay, fine. You are connecting Q bar here.
if we
Uh,
connect Q bar there, when Q bar is low, QP will turn on.
Q bar is low. Yes, you are right. And if Q bar is low, Q is high. So
So
this will
QN
also
will
be on
also
here.
turn on. So
Uh,
I think one buffer in one of the two has to be removed.
yeah.
Yeah, if it's not mentioned, one of them should have odd number of inverters, other even. So this looks
Yeah. I
incomplete.
think the
Either the
diagram.
upper one or yeah, lower one. One inverter is not available. One buffer is not. You have to remove one buffer.
Yeah, diagram is misleading here, I think. Yeah, you just yeah, one should have even and one should have odd.
No, but now they are flipping, right? So the buffer is nothing but a NOT gates, right? Two NOT gates. So
Yeah.
whatever, if you give Q, same Q will be there, right? So we want them to be in the opposite, right? One should be Q and Q bar, right? Is it not correct right now?
No, so like as I explained, if okay, you are giving Q bar here.
Yep,
So if now Q bar is high, for example,
yep.
so after these two inverters, again there is Q bar here.
Yeah, we'll get high right there,
Uh,
correct?
so this will
After
be
the
off.
buffers.
Okay. Assume Q bar is low, not high. Q bar is low.
Okay,
So this will be on, right? If Q bar is low, basically this
okay,
gate voltage is low.
okay. So it will be when the base is low,
Ah,
so it will conduct. Okay, on. Let's say it's on. Okay.
but now we have said Q bar is low, right? Here I said Q bar is low,
Mm-hmm.
correct? And this is work on.
Okay.
Here you are giving Q, right?
Yep.
Now if Q bar is low, Q is high, right?
Yep.
Now again, if the even number of inverters here, this is again high here. This is a high signal.
Okay. So it won't conduct, right?
No, this now, but this is a NPN transistor, right? So here, if it's high, this will also conduct,
Okay. Okay.
right? So both
Okay. Yeah,
are
the
conducting.
correct. The transistors
So,
are different. Okay.
yeah. So that will cause a infinite current to flow. Basically, that will cause a short between supply to ground.
So to have the same configuration, only we need to change the transistors. What should we do? Can we
No, no, you
have?
just have
Hmm,
to. So one in one branch you have even number of these inverters. One branch odd number.
okay.
So here instead of two, you just put one inverter.
Okay. So are these documents different? What you are showing, is it different from what is uploaded in the portal? Because I
Uh,
see the band, the center frequencies are different. You are saying 1 kilohertz, but I'm seeing 1 point something and six
oh, is it
626.
156, 156.5 and 625
okay?
for
I
frequencies.
think the
Yeah.
values are different, but rest of the things is same only. I think like circuits are the same. I guess only the values are a bit
Hmm.
different.
Okay, that's fine.
Yeah. So does anyone have any other questions?
Yeah, could you explain the second experiment? I just now
Okay.
gone through it, and
This one?
yeah, what is that exactly? I'm sorry, I'm behind everyone, but far behind, but I'm just catching up.
Yeah, so it's that is okay. So one thing is okay, before going to this, okay. Okay, so basically you want to drive your okay, this is Ramjet. You want to ultimately drive your speaker. Okay.
Yep.
So for that you are using this half bridge driver. Basically you can for now assume that to make this work here you have to have a PWM signal.
Okay.
So we have to get this PWM signal from somewhere. uh, so basically how do you do that? So now you are giving an analog input. This is a sine wave coming in the input
Okay.
signal. So now you have to, so this one is a single-ended to differential converter. Do you understand this?
No,
So this is
so
basically,
single-ended and differential converter means so it's creates some phase differences between an input and output. That's what that.
phase difference as well as it sets the common mode as well. So basically, uh, here you will have maybe a zero common mode signal, input signal.
Hmm.
This capacitor basically it, even if it has some other DC value set, this capacitor will like get rid of that DC value and make it zero, and then you set the common mode with this VCM. So that is one goal. The other goal is so as you can see, the top branch is a regular inverting amplifier, right?
Hmm.
So the output here will be minus
So that
R.
will create 180-degree phase
Yes,
shift,
it will
right?
be,
Negative.
but with a DC offset of VCM.
Yep.
And this node is basically your analog input as it is, it's coming.
Hmm.
Yeah. So this is what single-ended to differential converter. Now this you are passing through a comparator, and
Okay.
the you are comparing this signal with a ramp which you get from the first experiment.
Okay. RAM
Sorry, not
signal.
a
Okay.
ramp. I meant a triangular wave. Yeah, it's a ramp function only. Uh, so by doing this, basically you end up like this will comparing a sinusoid with a ramp will end up giving you a PWM signal. So you do that for both phases, and you get PWMP and PWMN that you use in the half bridge hedge bridge driver, which is your third experiment.
Okay. So H bridge driver is nothing but it's act as a buffer or amplifier, right? Something like that.
It is like yeah, it is an amplifier. It's like a like in a way a switching
It can
amplifier.
drive, right, more current, right, because
Yeah,
the
yeah, yeah, yeah.
transistor. Okay.
Because uh,
Speaker should be driven, right? That's
yes,
why.
yes.
Okay. Yeah, I need to read about how the comparator
Hmm.
helps to a comparator and input of ramp creates the pulse width modulation. Pulse width, right? Generates the pulse width.
Yeah.
Hmm. Because pulse width is based on the time, right? Time. Hmm. Oh, okay. Yeah, I will read. I need to work on that. Yeah. Yeah, now I understand at least what is the. purpose of this?
Uh, any other question for anyone?
Uday,
No, I'm just facing one difficulty that one of the channels in experiment 3, the output of the set reset flip flop or the set reset latch, it's not um, you know swinging between 0 and 5 volts. I'm not sure why it is happening. I've checked the connections and everything repeatedly, but still it is coming out to be high only for one, and for the other one it remains low. So for one channel I get the filtered output for one half bridge, and for the other one I don't. So I'm yet to troubleshoot that. Hope that is okay. I mean, till I come to the experiment and at IIT Madras and show.
You're saying this clock generator is not giving the correct output.
Correct. So for one half bridge it is working fine. For the other half bridge it is not working correctly.
So like one branch is working, the another branch is
Ah,
not.
no, no. We need two of these blocks, right? Half bridges.
Oh right, yeah, this is for PWM N and you'll have one more for the VW.
Right.
Yeah.
So for VPWM N, if I remember it correctly, it is working fine. For VPWM P, it is not working correctly. And that output is stuck. One of the outputs of the non-overlapping pulse generator is always stuck at 1. If I remember it correctly, Q output. And Q bar is, I don't recollect. So that is not behaving properly. So I'm yet to troubleshoot that. I have checked the connections repeatedly. Those seem to be fine as per the circuit diagram that I have drawn. Uh, so I hope that before coming to the actual lab at IIT Madras, I would be able to fix it.
Yeah, Uday, both are exactly identical, right? You can just copy paste it, the working
That is
one.
exactly what I have done. So now what I
Okay.
will do is I will just switch the channels to see if the problem shifts from one channel to another. I mean, uh, the the positive I will connect it to the negative channel and the other way around just to see if the problem shifts and if that gives any clue as
Okay,
to
if you
what might be
copy
wrong.
pasted exactly, make sure you have not copy pasted connections also. Like,
Yes,
you know what
I
I'm
have
saying,
checked
yeah.
the connections.
Mm-hmm. Should get done by some
Yeah.
debug session. Yeah.
So we can use one of these configuration, right? Because I see NAND gates and NOR gates,
Yeah.
right?
Yeah. Both
One
are
of them can be used, right? Two. We
yeah,
need two sets, right? Two
yeah,
sets of plug generator.
yeah.
Okay, I think we received 7400, correct? That's what I remember. ICs.
Okay. I'm not sure about what you have, but yeah, like what with whatever you have, you can uh, like build. So I guess you have NAND gates. Do you have this one?
Yeah, 7400. Yep.
So then you have to use the NAND gate. This one.
Okay. Or is there any ICs with these latches? Deep flip flop, right? It's a,
I'm not sure about that, but like I think you have to build this uh,
like this. Hmm.
with like the gates.
Okay.
Like you won't get an IC which directly gives you a clock generator. Any other questions?
No, sir. Question from my side. When we come to practicals at the campus, we will have to carry this assembled breadboards, right? There.
Uh, Ankit sir, can you answer this? Like from what I remember, the previous batch, like yeah, they brought the breadboard and then they showed that at the offline. Uh,
Okay.
yeah.
Okay.
So
And one
assembled
last.
one we need to show there. I mean,
No,
because
no.
sometimes.
So right now you make it at your home or wherever you are, and you upload the video. But when you come here, I think you'll be given time, and you have to build it from scratch at the campus.
Okay, so disassemble it and build again from the scratch all 4 experiments and show the full working. Is
Yeah,
that the expectation?
yeah.
Okay, understood. And one last query from my side regarding that half bridge.
Huh.
Uh, uh, yeah, so the QP and QN, and as per the equivalent model of the speaker, it is LR circuit, right? So there would be a lot of inductance also. And when it is PWM, when the transistor, either QP or QN, would turn off, there won't be any alternate path for that inductor to release the remaining energy, right? So if it had been MOSFETs, there could have been anti-parallel diodes, but in this case, it's not there. So do we need to add those?
No, no, like I think you're just complicating a simple thing. Like you just like do whatever is being shown here. That should be enough.
Okay, understood. Okay.
Apart from that, any other doubts? Okay, so if no doubt, Uday and Dhanraj, so we will stop the session.
Okay, yeah, thank
One
you. Yeah, I
one
will
fi-
try and send
Yes,
the
sir.
queries through.
yeah, one
Okay.
final query. It's going to be for 2 days, right? Half day
Yes,
and day.
yes, yes, yes.
So that means about 8 hours. So in 8 hours, we have to reconstruct the whole circuit
8 and
again.
8, 16 hours.
Okay. So one full day, right?
2 full day.
Okay.
Two.
Oh, yeah. Yeah. Okay. Fine.
2 full day. Either three or fourth or five.
Yeah. Okay.
Okay.
Yep. Thanks.
Okay. Anything else?
Yeah, I'm good for now. Thank you. Yeah, I will try
Okay.
and if any questions, I will
Fine.
put it in the chat.
Okay.
Thank you very much for arranging
Thank
this session.
thank
Thank you all. Have a good
Yeah.
evening.